Hey there, Year 11s. I gave out this worksheet last session on the Friday. Yeah, I can't remember. Just last lesson. So it's probably the Friday. Sketching quadratic graphs. Now, this worksheet may be challenging for quite a few because it assesses all the skills that you need in order to sketch a graph, right? And what I'll be talking about this in class, and what I want you to sort of understand is when you're when you're learning to sketch the quadratic graph, there are only three things you need in order to sketch a graph. You need, one, the y-intercept, okay? We need the turning point, and the x-intercept, okay? Now, what I want to clarify one thing where a lot of students tend to do this because of Year 9 mathematics. When you get y equals 3x plus 7, for example, a lot of students will know that this is the y-intercept, and they'll continuously say that. But a lot of students don't seem to know why. You see, they're just like, because that is the y-intercept. But then when I give a similar equation in Year 12, and I say something like, 2 over x plus 3, then a lot of kids still say this is the y-intercept, okay? And that also then happens with, equations. When I gave you guys the turning point form, so let's say 2 times 2x minus 1 squared plus 4, a lot of us still think this is the y-intercept. And what I want you to understand is that is not the y-intercept. It's not always. It's just because in Year 9 you learnt this is the y-intercept and you kept getting it right. You keep thinking that's therefore any number by itself must be the y-intercept. No. You see, you think about what does it mean when we say the y-intercept, we sketch the graphs of any graph, doesn't matter. Y-intercept just basically means when you happen to cross the y-axis. True? And the very one concept you need to understand is the y-intercept, right here, this is the y-axis. We know that no matter what the coordinates are, now let's say if I labeled it, if I said 1, 2, 3, 0, and -1, right? If I asked you to label the coordinates, what you would have said is this is 0, 3. You would have said x is 0 and y is 2. So you said 0, 2. X is 0 and y is 1. X is 0 and y is 0. X is 0 and y is -1. That's what you would say if you were to label those coordinates just now, right? The commonality is what you don't seem to realize is x is always 0 on this line. Doesn't matter where, it doesn't matter what graph you have. As soon as you cross that line, right on this line right here, which I'll highlight just in case you couldn't see, on this line, x is always 0. 0, 0, 0, 0. Yeah? It's just like saying, if I had a coordinate on the x equals 1, if I did x equals 1 here, and I did coordinates here, coordinates there, then x will always be 1. It just so happens that the coordinates are always on x equals 0. That's the y-axis, right? So, because of that, that's why we know when we have a y-intercept, which is any graph, and it crosses the y-axis, of course, x is always 0, because that's the vertical line when x is 0. Okay, this is the vertical line when x is something else, x equals something else. This is the vertical line when x equals 1, right? So, let's go back to my point. Y-intercept is when we know x is 0. So in the examples I just made up before, doesn't matter what the equation I give you, even if I gave you y equals 3x plus 7, why we know this is called the y-intercept is because when x is 0, this will tell you what y is. Okay, so let's have a look. If x is 0, then what do you have? You got y is equal to 3 times, what if x was 0? 0 plus 7. So it naturally makes sense. 0 plus 7, y is equal to 7. That's why we know when x is 0, y is 7. That's the y-intercept. So if you were to plot 0, 7, you'd say that's 0, 7, right there, 0, 7. That's why in linear equations back in Year 9, you're like, that's always the y-intercept. Now that's the same thing with any other equations you're going to get. Okay, any other equations? So the one I just made up before, I said 3 bracket 2x minus 1 all squared plus 4. This is not your y-intercept. Why? Because if you want to know what your y-intercept is, it's when x is 0. So you want to work it out. Y equals 3 times and 2 times 0, because that's what we said. X is always 0, right? X is always 0. Minus 1 squared plus 4. Let's work it out using BODMAS. 2 times 0 is 0. Minus 1, square it, and then plus 4. 3 times negative 1 squared plus 4. Negative 1 squared. 3 times negative 1 squared is 1 plus 4. And going through BODMAS, 3 times 1 is 3 plus 4. 7. So what does that mean? It just means y is equal to 7 when x equals 0. So that's a coordinate of 0, 7. That's your y-intercept. So for the y-intercept of this graph, it is 0, 7, right? And it doesn't matter what equations you get. So even if I gave you any of these ones on the sheets, you want to know what the y-intercept is, let x equals 0. So in this case here, you have y equals 4 times 2 minus 0 squared. That becomes 4 times 2 squared, which becomes 4 times 4, which is 16. So that means when x is 0, y is 16. There we go. I've got my y-intercept. 0, 16. Okay? And that similar concept also now applies to even this equation. When x equals 0, y is equal to 2 times 0 squared plus 8. And 2 times 0 is 0 plus 8, 8. So I got when x is 0, y is equal to 8. So that's my y-intercept, yeah? So when you're sketching graphs, it's easy to find the y-intercept because all you have to do is substitute 0 in. That's all you do. For any equations from here on, doesn't matter what equation you get, that's the theory, right? Now, using the same idea or sort of understanding, we are now going to try to find the x-intercept. Now, x-intercept is the same thinking. See, x-intercept is when you have a graph that crosses the x-axis. And, you know, that all crosses the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Now, if I labeled it 1, 2, 3, 4, and I asked you to label those coordinates on the x-axis, you would say that's 1, 0, 2, 0, 3, 0, 4, 0. There's a pattern. What's the pattern? Y is always 0. Because this is when the line y equals 0. Up here is when y equals 1. Up here is when y equals 2. Right? So that the x-axis happens to be when y equals 0. So really to find the x-intercept, it's just when y equals 0. And really, to be frank, for the last 2 years, year 9, year 10, you're really just doing that. I mean, that's all you're solving for. You're just trying to find the x-intercept. All the skills you've been learning, cross method, to factorize, complete the square, all of it was to help you learn the skill to find x-intercepts. See, if you actually go back to your textbook, notice why everything equals 0. Let's go back. Let's have a look at this. Look, I'm going to take you all the way back to 3e. Have you ever wondered why they're all equal to 0? Look at that. 0, 0, 0, 0, 0, 0, 0, 0, 0. Why is that? Because what you're actually doing here is this is a quadratic equation. It's just y equals to x squared minus 2x minus 1. And if you want to find an x-intercept, what do? Let y equal 0. That's why you got 0 equals to x squared minus 2x minus 1. And your job is to solve for x. Yeah, and in this case, they told you to solve for x. So what are you really doing in this case here? All of this question, if you've done it in exercise 3, you just found the x-intercepts for each and every one of these quadratic equations. That's what you've been doing, yeah? If we go back a step, let's go back to another exercise as well. You'll notice why they're always equal to 0, because that's all you're doing. You're just learning to find the x-intercept. Let's go to, look at that. Look at a whole bunch of that. They're all equal to 0. Check that out. 0, 0, 0, 0, 0, 0, 0. Yeah, it's all equal to 0 because, again, notice this is a possible quadratic equation where you could have y equals to x multiplied to 2x minus 4. Okay? And they're just saying, well, if you want to find the x-intercept, what do? Let y equal to 0. And you've been using null factor law so that you can work out the x-intercept. So in this case here, this is 2x minus 4 equal to 0, and that becomes 2x equals 4, and then x equals 2, right? these are your x-intercepts. That's all you just found out. You found out when it's x is 0, y is 0. When x is 2, y is 0, because that's what you did. You said y is 0 right here. You said y is 0 to find the x-intercept. Those are your two x-intercepts. Okay? So every technique you've been doing so far, all of these questions here, is to find the x-intercept. And that's why I said 3b, 3c. You can't factorize using cross method. You can't solve for x-intercept. You can't solve for x-intercept. You can't sketch. If you can't sketch, you can't analyze, and hence you can't do application questions. Yeah? That's why it's so important for you to have learnt back in year 9 to year 10, to have learnt this method, this cross method that you learn. You had to be proficient with it. So you had 2 years to sort of master this skill here, learning to factorize it, and then learning to use null factor law to solve, because at the end of the day, all you're really trying to do is find the x-intercept. That's how simple it is. Yeah? So going back to the worksheet that I gave you, so here we found the y-intercept, which is 0, 16. That was easy. Okay? But then now let's try to find the x-intercept. See, x-intercept is the one concept. It's just saying, well, what happens when y is 0? Because that's what we want to know. When y is 0, I know that's the x-intercept. So I'm going to say, all right, that's 0 equals to 4 times 2 minus x all squared. Right? And it's not anything tricky at this point, you see, because you're just doing inverse operations, what you learnt back in year 7 and 8. This is 4 times a number. You want to remove the 4 because at the end of the day, you're trying to find x, right? So I'm going to divide 4 because it's times 4. Divide 4 on both sides. 4 divided by 4 cancels out to be 1. What do I have? I now have 0 divided by 4, which is 0. 4's cancel out to be 1, so I now got 1. We don't normally write the 1. 2 minus times 2 minus x squared. And how do you remove the square? Same thing again. You say square root. Opposite of that. Square roots cancel out. And now you get an answer of 2 minus x, because the squares cancel out. But remember, when you square root, it's a plus minus square root of 0, which is 0. But really it doesn't matter because it's 0. And in this case here, a lot of students feel the need to minus the 2. You don't have to. See, for me, I'm looking at this and I'm like, that's a minus x. I don't like minus x. I want positive x. I'll say plus x. Plus x. We're balancing the equation. It's okay. Negative x plus x cancels out to be 0. And now I have 0 plus x, which is x, is equal to 2. Voila. Okay. And that tells me my x-intercept is when x is 2, y is 0. So here we go. X is 2, y is 0. Okay. And it's likely that the graph is going to look like this. How do I know that that's what the graph looks like? Well, that's why I taught you in exercise 3D to figure out by reading the turning point form. See, this is a turning point form. This is my A. A is 4. There is no C or the number that you add on, so it doesn't go up or down. 4 tells me that it's narrow because it's bigger than 1. And it's a positive 4, so it's a smiley face. It's a thin smiley face, right? This here is what you're squaring. That will tell you left or right. It's what I taught you. And I said the technique I showed you in class, I said let it equal to 0. Solve for x. Add x on both sides. 2 equals x. It's a positive 2. So what does that mean? 2 to the right. Which is what I did here. 2 to the right doesn't go up or down. And we know that the y-intercept was 0, 16 from what we worked out before. It's a smiley face. Bam. Graph done. Go on to the next one. Same idea. Okay, I found the y-intercept was 0, 8. Okay, so I'm going to label it 0, 8. So that's 0, 8. That was my y-intercept from previously. And now I want to find out my x-intercept. What do? Same thing. Y is equal to 0. You got 2 times x squared plus 8. It's all inverse operations from here. So we see that's a plus 8 there. Now, there's a lot of ways to do this. You can do it, try to read the equation. I'll read the equation afterwards, but let's do it algebraically. Minus 8 on both sides because it's plus 8. 8 minus 8 cancels out. You got negative 8 equals to 2 times x squared. Divide both sides by 2 because that's times. That's times 2, so divide 2 on both sides. 2 divided by 2 cancels out, and now I get x squared is equal to negative 4. But the problem is when I square root now, we can't square root a negative. Or square of any number will never give you a negative number, so this is undefined. You can't do this. You can't type that in the calculator. Square root of negative 4 won't work. So what does it mean? It seems like you don't have an x-intercept. It's undefined. Did we do a mistake? No, we didn't. read the equation. This is why I taught you in exercise 3D to read it. Look, y equals 2x squared plus 8. If we were to read it, see, 2 is the a value. It's the number of times to whatever you're squaring, right? So it's x squared. 2 is your a. It's positive, so it's a smiley face, and it's a bit narrow. Plus 8 means up or down. But in this case, it's positive, so it's up 8. And now if you want to know who moves left or right, it's what you're squaring. You're squaring the x, so let x equal to 0, and that means not moving left or right. So how does that make the graph look? Well, think about it. Smiley face doesn't move left or right, and it goes up by 8. So think about it. From here, doesn't go left or right. It just goes up by 8, and it's a smiley face. Bam. Done. See how easy that is? Okay, so every skill that you're learning, you're going to sort of apply it. So if I do the sort of the third one here, so we have a look at the third one, same idea, Xintercept, you're going to let y equal to 0. So 0 equals to x minus 3, x plus 4, and this goes back to exercise 3C. It's all about finding the Xintercepts, null factor law, yeah? You got two numbers, magic square times magic square, equals 0, so that means one of them has to be 0. True? Logically. So therefore, if this was equal to 0, x minus 3, if it was to be 0, then what should x be? In our case, we can say add 3 on both sides, x equals 3. Yeah? And that just tells me when x is 3, y is 0. That's y. Don't forget that. This is y. I said y equals 0. So that's my first coordinate over Xintercept. And the other one, well, maybe x plus 4 was meant to equal to 0, and you minus 4 on both sides, and then x becomes negative 4. So what does that tell me? Just when x is negative 4, y is 0. So if you sketch that, you just put in the points here. Say 3, 0. That's my Xintercept. The other one was negative 4. Negative 4, 0. Okay? But I still need three things. Remember, I need the turning point, I need the y-intercept, and the x-intercept, right? And here we go. So if I were to do this question, I wanted to find the y-intercept. Okay? Y-intercept is when x equals 0. So that's what I'm going to do. Y equals to 0 minus 3, 0 plus 4, and that becomes negative 3 times 4, which is negative 12. So what does that mean? It just means when x is 0, y is negative 12. So in that case there, yeah, it's probably further down, but let's just say 0 and negative 12 is here. There you go. Now, I just don't know what the graph, where the turning point is. I mean, it could be over here, it could be like that, or it could maybe go through like that and come back up. I don't know. Okay, so you got to learn to find your turning point. And at this point here, the turning point, remember, is actually the axis of symmetry, or the middle of the graph. So there's two ways to do this. If it's in the middle, well, think about it. From negative 4 to 3, where's the middle? You know, is the middle over here? Is it over there? Over there? How do you find the middle from negative 4 to 3? Okay, so you can count the number of digits. From here to here is 4. From here to here is 3. So 4 plus 3, that's 7. So if you want to find half of 7, it's 3.5. So if I just go here and here by 3.5, then I should find the middle. True? Okay. So it just means that the middle is obviously negative half. Okay, and so if you know x is negative half, then how do you find out the y coordinate if you know x is negative half? Well, the only other way to find out is it says y equals to, we know it's at negative half, minus 3, negative half, plus 4. That now gives me, what is this? Don't we all hate fractions, don't we? Negative 6 minus 1 minus 7 on 2 times negative 8 minus 1. No, 8 minus 1, 7 on 2, negative 49 on 4. Okay, so that's about, what, negative 49 on 4 is about negative 12 and 1/4. So just a bit below, so it's over here. And there we go, we put all our points together. There you go. You got your turning point at negative half, negative 12.25. Now, the only reason why that question might have been tricky is because it's got fractions in it. If you're wondering how I found the middle again, it's sort of, I'll do it this way so you sort of understand what I was saying before. How did I find the axis of symmetry? If I told you that this was 2, negative 2, and this was 2, then where's the middle? Most of you would know it's at 0, but the question is, how did you know? See, from 2 to negative 2 to 2 is a distance of 4. Half of 4 is 2. So if I move 2 from the left and 2 from the right, obviously it's 0. That's a logical way of figuring it out, that x equals 0 is the middle. The other way is, if you know the x-intercept was from -2 to 2, then you can find the average. So -2 plus the 2 divided by 2. Yeah, you know how to find the average. Add the sum of numbers divided by number of numbers. So in our case here, it was -4 is my x-intercept, plus my other x-intercept is 3, divide that by 2. So -4 plus 3 is -1 divided by 2. X is -half, which is what I have. Yeah, finding the average is another way to do it as well. Find the middle. But yeah, so that's the gist of what I want to show in this video. I will explain more about this for tomorrow's session, exercise 3F, about sketching equations. So if you have a look at exercise 3F, so I'm just quickly do a quick view for you to see. 3F, no. There we go, 3F. I'm interested in getting you all to sketch these equations, okay? So you learned how to sketch turning point forms. I want to teach you to sketch now general forms. And it's the same idea. In fact, it's easy to find your y-intercept from this form. You can try to factorize this, completing the square or cross method. That's how you find your x-intercepts, y-intercepts, and then you can find your turning points and then sketch the graph. Yeah. But that's why I needed you to be able to read turning point forms, which is exercise 3D. So if you did 3D, let's have a look at 3D. Remember when we did these graphs? Okay, see these graphs here? I asked you how to read these, and I said, you know, this tells you up 1, to the right by 2, right 2. It's a positive graph as well. You know, I told you to roughly sketch it. So to the right by 2, up by 1, and it's a positive graph. So that's my rough sketch of 3A. That's what I asked you to do as part of your homework for exercise 3D, reading turning point forms. That's important because then you learnt completing the square to get this. So you can read the graph, okay? They all go hand in hand. So really the most important exercise for your foundation to sort of prepare yourself for year 11 is everything you've done from year 9 to 10 is to help you, and we're revising it again, exercise 3A to 3F. That revises everything you need to know, yeah? Afterwards, G is still easy, but anything onwards, and H is still easy as well. Anything onwards, I, J, and K becomes difficult because you need to understand all of this beforehand, okay? So please do your exercises. Exercise 3B, C, D, E, and F. They're very important. Okay. Thank you for watching how to find x-intercepts, y-intercepts. I just wanted to clarify that point, that when you're finding x-intercepts, you let y equal to 0. When you're finding y-intercepts, you let x equal to 0. It's as simple as that. But we'll be doing more of these graphing tomorrow for exercise 3F. Okay. Thanks for watching. I'm going to finish off the video here, and we'll talk more about it in class. Okay.